I'd like to start by telling you about a popular Facebook page called Humans of New York, which is one man's attempt to catalog the beautiful stories of, you guessed it, people in New York. He's very popular. He's got over 17 million followers, so he's essentially the entire country of Ecuador. I'd like to share one of his collected stories with you. I tried to fight it at first. I told myself it was all in my mind. I did mental exercises, I went to experimental trials. None of it worked. If you tell me a name, I'll forget it in 5 minutes. 1 minute, actually. They have a few medicines, but the effects are negligible, so I don't even bother with a doctor. I read as much as I can, so I can hold on to words and spelling for as long as possible. But other than that, there's nothing left to do but wait. Imagine that's your hand on there, your story, your prognosis. This is what we're up against in the Neuroscience Research Institute. Over the next 2 decades, the number of Americans with Alzheimer's disease is projected to double to 8 million. That's the entire country of Israel. We've got a lot of work to do. We need to know more. Fortunately for us, we've got a good lead. If we are going to have any hope of figuring out what is killing these brain cells, we need to know what might be involved. Tau is a protein expressed primarily in the brain. It stabilizes the skeletons of your brain cells. It's also present in Alzheimer's patients, but a lot of it is in a different form, in the form of these big protein tangles. If you've ever put a pair of earbuds in your pocket, you know exactly what this looks like. Now, some proteins can link up and form something called a dimer. It's like having 2 pieces of Velcro. As they get close together, they link up and form that dimer. Some proteins also have electric charges on them. And if you look at the electric charges on tau, you see something very interesting. It's possible that the electric charges on tau are causing it to zipper up and form these dimers. Now, some proteins form dimers in order to function properly. So if tau, a protein involved in Alzheimer's disease, is forming these dimers in our brains, we need to know, because that can reveal a lot about how tau works normally as well as in Alzheimer's patients. This is where I come in. My independent project has been to tag tau with 2 special markers that will light up like the 4th of July when I tell them to. This can allow me to measure the microscopic distances between tau proteins to see if they're forming these dimers. A lot of progress has already been made. I've been able to successfully amplify and isolate tau protein as well as the 2 markers I plan to use. The only thing left is for me to glue them together and measure the distances. This is really exciting because if we can better understand tau and Alzheimer's, we can give that hand, that man, those 8 million people, a fighting chance in the future. Thank you.